Welcome back to the series Build a Large Language Model from Scratch. This is the part number two, where we're discussing about the working with text data. So in our part number one, we actually discuss about three stages. Stage number one, stage number two, and the stage number three. So in our first stage, we actually building here an large language model. So let's say building an LLM. And then in stage number two, we pretending the large language model on unlabeled data to find, or you can say obtain, a foundational model. Okay, foundational model. Or you can say this is the training part. This is the training part. In the stage number three, we basically fine tuning the large language model in some specific domain. So we discuss about two things. One is nothing but for the classifier, for the email spam or harm, and second one is for the personal assistant. If you miss it out, please check out video, link will be in the description. You can go on here. Otherwise, you can search on the knowledge actor build and large language model from scratch, the first video one. Okay. Now, in the stage number one, we basically do three things. One is called the data preparation, or you can say the sampling. It's a sampling, and also we do the attention mechanism. I just make it the ME. And third one is the LLM architecture itself. So here we're discussing about this data preparations, and we are working with data. Okay, working with text data. Now the question is, we know that our deep neural network is nothing but our large language model is nothing but an deep neural network itself. So our large language model is nothing but one neural network itself. So you basically process the textual data, or you can say we process the raw text data, which one is also called as a categorical data. So because the large language model is a neural network architectures, so we need to do some kind of mathematical operation, right? We need to do some mathematical operation. So we are unable to process, we are unable to apply it to the text data. So that's why we need to convert in this text data into some kind of vector representation. You can also say that one kind of vector format. Okay. So it maybe have some different types of data. For example, it can be the video, it can be the audio, or it can be the textual data. Okay, you can use any kind of data in terms of large language model, because here if you using here the ChatGPT, you can also upload the images, you can also give the instruction to the ChatGPT, right? You can also upload the audio itself. So that's we need to also process them. So our neural network is unable to process the raw text, the audio, or the video sample. So for that, it will try to creating here some kind of embedding. Okay. So what is actually embedding? Embedding is nothing but one kind of neural network architecture itself. Let's say for the text data, we are going to passing to it inside a neural network. Inside a neural network, let's say this is a neural network. So it will give me some kind of embedding vector. So let's say this is one kind of embedding vector. So one kind of embedding vector, let's say this is, let's say 1.78, let's say 0.24, let's say minus 2.10, let's say 2.54, like that. Okay. Same thing for video. Let's say video, it's nothing but one kind of architecture. We're going to passing it out You can say as a embedding model. You can say as a embedding model. We basically needing here this kind of textual data. I mean numerical data, because we know that textual video and audio is a non-numerical data. Same thing for the video, it will process them and it will give me some kind of vector representations. Let's say 1.28, let's say minus 2.7, like that. Okay, blah blah. Same thing for the audio. But here one more things, I mean one more important thing to note, that in the case of text, video, and the audio, the architectures of the neural network is different. Okay, the architecture of the neural network is different. Okay, I just make you, I mean teach you from this book, built a built a large language model from scratch by Sebastian Raschka. Okay, you can get all of the things in this book. So now, as we know that the core concept of an embedding is mapping from distinct object, such as word or the image. You can also process the image or even the entire document to point in a contiguous vector space so that our neural network can understand. So while what embedding are the most common form of text embedding? Okay, we know that what embedding is the common from the text embedding. I mean, we process the text. So they are also embedding for sentence as well. Embedding for sentence, 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 as well as for the paragraph. Okay, see word, image, and the entire document. Okay, also have the sentence and the paragraph embedding. So sentence and paragraph embedding are mostly used, are popular choice for the retrieval augmented generation, also called as a RAG. Okay, it's called the retrieval augmented generations. So what is the retrieval augmented generation actually? The retrieval word mean it will retrieve something from, I mean something means context from, I mean retrieve context from vast, or you can say large knowledge base. So in case of knowledge base, it can be the vector store database. Okay, vector store DB. I mean the Chroma DB or the StarDB. So if you don't know what is RAG, you can go and check out the video about the RAG in my YouTube channels. I already create about that. The how can you create the RAG using the Llama model, the Grok, or even the DeepSeek R1. I mean the Chinese model. Okay. So augmented and generation mean it will actually producing some kind of text. So see, we need to encode. I mean, we need to actually embedding this word, image, and the textual data. So several types of algorithm or framework are actually available. It has been developed to generating here the word embedding. So one of the earlier and the most popular example is word to backed. Word to backed. So it's widely used in case of NLP tasks, I mean natural language processing tasks. So what to backed is a trained neural network architecture to generate what embedding by predicting the context of a word. Okay, the target what? Okay, sorry, गलत क्या? Context of a word given the target word. Okay, given the target word. That's been the main idea behind this word to backed is the word that appear in a similar context tend to have the similar meaning. See, again, I repeat again. The main idea behind the word to backed is that the word, see, the word, array bhai, the word appear. Okay, see, बहुत important है. Appear in similar context, let's say similar context tend to have similar meaning similar meaning. So what it does actually mean, let's take one example. Okay, let's take one example. Let's say I have two dimensions. For the illustration purpose, I'm taking here two dimensions. In the case of water bag, you have the one to thousands of dimensions it maybe have. So let's taking one graph. So that's say let's say this is our first dimension, and let's say this is our second dimension. Okay, let's say second dimension. So in our first dimension and second dimension, let's say I having some bird, let's say eagle, let's say goose, let's say duck. Also, let's say some city, let's say Germany, let's say Delhi, Kolkata, Kolkata, let's say London. Okay, let's say having some kind of degree. Okay, let's say long, let's say longer. Okay, long longer. Let's say longest. Okay, so those are the word are related to but. Okay, obviously those are the data or what are related to but, and those of the data or the word is related to a city or a country. Okay, let's assume this as a city, and those of them are related to some kind of degree. Okay, superlative or the comparative. That's mean in the case of what to back a tool, creating here a vector embedding of different types of bird, different types of city, and different types of degree. That's mean but is the same context. That's why you can see appear in the similar context tend to have the similar meaning. That's mean eagle meaning is similar, duck meaning is similar, the ghost meaning is similar. Same thing for the city. It is a city, Delhi, Kolkata, or the London are the city. Same thing for the degree are the similars. In the case of what to back. Now, now, so so in case of LLM, in case of LLM, it's nothing but a neural network. Okay, let's take in the red one. It's a neural network, so it need to be trained, right? So while we can using here some kind of pre-training model such as what to back to genetic embedding for the machine learning model, we actually is using it this what to back for the actually machine learning model. Okay, it's using here the machine learning model. Okay, let's say ML model, but LLMs commonly using their own embedding, using their own embedding that are part of input layer. Okay, part of input layer are updating during the training. That's when one kind of updation is happening. One kind of updation is happening while we do the training. It's called the back propagations. It's called the back propagations. So the advantage of optimizing the embedding part of the LLM training is instead of using the what to back, is that the embedding are optimized for a specific text and data at hand. Let's say I take you an example. Let's say river bank. Okay, let's say let's say river bank, and let's say I have one just bank. So what to back it to? This bank and this bank have the similar meaning that you see in the example, right? That you see in the example, similar meaning, but the river bank and the bank what is not similar, is not similar. That's what to pact is not used. As well as we see two dimensions. Okay, we just see the two dimension. So if I take in the example of the GPT-2, it have the 117 million to 125 million of parameter, as well as the dimension is 68 dimension. Okay, I mean the size of the dimensions. Okay, so you are unable to visualize them, just to visualize the two of them for the illustration purpose. So for the GPT-3, it's nothing but 117.5 billion parameter, and the dimension is 12,288. So we are unable to visualize them. We are unable to visualize them. That's all about the text embedding. I mean, how it will actually work, and the earlier version of the models. Now let's go to our actual part. I mean, our actual topic for this video. So in order to actually preparing here the embedding used by the LLM, we need to splitting the text first. So we need to first splitting the text. So splitting the text into word, and second we need to converting the word into token, into token, and we need to turning the token into embedding vector. Okay, embedding vector. So let's discuss how we actually splitting the text into some individual token, required preprocessing step for creating the embedding for a large language model. So this token are either individuals word or special character, or including here some kind of punctuation mark. Okay. So how you can take in this? So let's take one examples. I just take it from this book. So let's say I having one sentence called this is an example. Okay, this is an example dot. So first we see that we need to splitting the text into word. Okay, let's split it. So how can you split them? Let's say this is one word, and is another word, and is another word, and example is another word, and dot. I mean the full stop is another word. Okay, this is called the tokenization. This is called the tokenization. Tokenizations. So it's better we can illustrate it. I mean we can see here one applications that is available in the Bercel. I hope so. So I hope this is the this one. Okay, so you can see that. Okay, I actually removing this actually my keyboard. I don't have this port. So let's try to give here. I mean connecting here my keyboard. So okay, I connect the keyboard because I just have the three port. So in one port I have my this drawing pad, and another port I have my microphone, and in the another port I have a mouse. So that's why. So let's give it here one text. Let's say hello, I am. Let's say give it a small letter. Let's say I am Mishudhar Chandra. Okay. So I just give it here one kind of text, and you can see it internally using here GPT-4o, and token number of I mean total number of token count is 9. So see for the hello it will making here a tokens ID. So 13225 is the token ID, and for the 11 it will taking as a comma. Okay, you can see we see that in case of large language model it also countering here the special a special character or the punctuation mark as well. So 357 is I, and this is for M, this is for the M, this is for the I as each U because it's a name, and it is for the dhar, and it is for the cha, and it's for and do. Okay, it will creating here some kind of I mean it give here some kind of unique ID. Okay, this is how actually tokenizer is work. Or by internally, this is actually using the byte pair encoding. So we'll discuss this later on. And this byte pair encoding is used by our large language model. So this is how it actually work. So now let's go on the full screen mode again. Okay, so it will try to connect the text, and for the corresponding text it will give here some kind of token ID. Okay, it will give some kind of token ID. Let's say I give it here, let's say 40, let's say 40134 as a token ID of this, and let's say give it here 20, let's say 52 as a token ID. Let's say this is for 133, and this is for let's say 389, and let's give it the 12. So this is the token ID. So this is our input text. So you can say that input text, and this is called the tokenized text. So let's say tokenized text, and this is called the token ID, token IDs. And then we have one embedding vectors. Okay, we have one embedding vector, and this embedding vector we need to passing to our large language model. Okay, so our large language model is a decoder only model, or you can say decoder only transformer. So this is for the token embedding. We can say that token embedding, and we passing this into one GPT decoder. Okay, GPT decoder transformer, or you can say that as a LLM. Okay, as a LLM, because you know that LLM is a decoder only model. Okay, and after that it will process them. It will process. Okay, it will go to some kind of post processing step. Okay, step मैं थोड़ा speed जा रहा हूँ. Then it will give the output. That's mean in case of tokenizing the text, first you need to take in the input text, then you need to convert them in some kind of tokens, you need to give here some kind of token ID, and then you need to make them into some kind of token vectors, and we pass it to our large language model, and after that it will do some post processing, and it will obviously give some kind of output. Okay, so now we start our coding part. You can start our coding part using Python programming language. So we are using here the Jupyter notebook. And then for the testing purposes, we are going to using here data sets called the verdict, the verdict. Okay, the verdict. So a shortlisted by edit the Wordthon. So let's edit Wordthon. Okay, from the wiki source. Wiki source. Now let us start our coding right now. But before that, let's see our data sets and then we start our coding in our Jupyter notebook. So the verdict from the wiki source, just search on Google and you can getting this link wikisource.org. So you can see a small standard and the large scale is available. So we are just going to using here this small one. So you can also use the large one if you have the more amount of GPU, you can use it. So now we can start coding right now. So I have already it inside my directory. You can see it's already available in my directory, the verdict.txt. Okay. So I'll give this inside your inside my GitHub repository. You can easily access it. Now what I can do first, you're going to reading this verdict.txt. So we can using here with statement, let's say with open, and then you can give it here the verdict, let's say the verdict.txt, and you can give it here the mode, let's say read mode, and then it also give it here one encoding technique. I mean encoding as UTF-8. Let's UTF-8. So let's make it as SF, I mean as a file, and then you can simply going to read it. Let's say f.read, and then let's make it as a raw text as a variable. Let's say raw text. Okay, so now we can also printing it out. Let's say let's printing it out. Let's say print. Okay, इसका थोड़ा off कर देते इसको. Okay, let's make it print. We're just printing here the total number of character. So let's say total number of character. Okay, and you can simply going to give it here the length of the raw text. Okay, that's the length of the raw text, and then we can simply go into printing the raw text. Okay, we can printing the raw text. Let's printing here first 99, or let's say first 100. Okay, so we have the total number of character is 20479, and this is the first raw text with having the 100 characters. So I had always thought Jack Gisbergen rather a cheap genius, and we can see some kind of special character that we have um, in our the verdict.txt. Now our goal is to tokenizing here this text into 20479 79. Because if I see that, you can see you need to convert them into uh, some kind of tokens. That is called, this is a uh, examples of tokenization that you can see on here, tokenized text. And after that you are going to convert them into some kind of token IDs. Okay, now let's see how can you tokenize the text. Okay, so this is the book that you can see, same thing. I will draw here this graph, and you can see it will look converting this token into some kind of ID. So we'll do it later on. First we need to do here the tokenize this text. Let's do it. So what you can do, we're simply going to using here a library called RE. Let's say import RE, also called the regular expressions. Okay, so let's taking here one text for the illustration purpose. So let's say we actually basically using this one in order to convert them into some kind of tokens. So let's say hello, let's say hello, let's say comma, let's say world, let's say dot, let's say this is a text. Just you're going to test it out to an input text, and after that you're going to apply it to the raw text itself. Now let's try to uh, creating here re dot split. We are going to split it, okay, based on the sentence, okay, based on the space. So let's give it here a space, okay, based on the space we are going to split it. So I need to take it like that in here. So based on the space, okay, and then we're simply going to give it to here the text, and you're going to printing it out. So let's make it as a variable called result, and after that you're going to printing this out. Let's say print the result. Okay, कैमरा थोड़ा इधर आना पड़ेगा बस now. Okay, so you can see hello world, this is a target. Okay, okay, I think so the r should be the out of that. Okay, that's why the space is not encountered. Okay, now it is fine. Now you can see here it will creating here the word into some kind of token. You can see hello, then it have the it countering the space as a token at itself because it is splitting them. I mean based on space, the word dot is a tokens space, this is a token, again a space, is a token, as a token, and the test is a tokens that you can see in case of re. Now the result is a list of individual word with the word space as well as the punctuation character. Okay, if I give it here, let's say I just give it here this question mark, it will also creating here this punctuation mark or the special character as a new tokens. Okay, now this is a simple tokenizers schema, mostly work for separating the example text into the individual word. But however, some word are still connected to punctuation. You can see word dot, okay, word dot. Some the word is connected to the special I mean punctuation characters. So we have to separate the list entity as well. I mean we need to also separate here the word dot. I mean we need to making this dot as one individual tokens. Okay, individual tokens. So we need to also make it as a lowercase letter. So it will actually help us the large language model to distinguish the between proper noun or the common noun. Okay, it will help you do that. Okay. Now what I can do is simply going to removing here this white space or the dot from here. I mean we split it based on that. Okay. So what I can do is simply going to copy this out. I mean this result we can also copy this out. We're just changing inside this r. Okay. So in here what I can do is simply going to creating here a list because you're going to give it here so many data. So you give it here the comma and the full stop. Okay, you give it the comma and the full stop, as well as we're going to give it here the space. Okay, that's a space. Now if I see that, you can see here it will encountering this dot as a token, encountering this dot as a token. See, this is a test. See, this is a test. Okay, right now. Okay, so I think we do any kind of mistake. So we give it here this one, we have the dot, so we have the comma, we have the dot, as well as this one. Okay, I need to also remove this space because we are not able to give the space on here. That's why it's actually encoding this was as a space. So hello, you can see comma as a separate tokens, and you can see the space as a secret token, and the word and dot as a separate token. You can say space, a space, and this. Okay, it will try to encounter it with one I mean every special character as a tokens. Okay, so a small remaining problem is that the list is include the white space character, because see it will include here some kind of white space characters. So optionally, so we can remove the redundant character safely, we can follow. So how can you do that? We can using here the strip method. We can use the strip method. So let's creating here one list comprehensions. So what we can do, we can take it, let's say for item in result. Okay, let's say result. So if, okay, if the item dot strip, I mean we simply going to stripping this out in order to removing the white space from here. So you can directly pass it. Okay, for item in result, I mean it's available inside my result, and we strip the item. Okay, strip the item for the white space removal. Let's assign into a variable, let's say result, and then we can simply going to printing this out. We can printing this out, let's say print here the result. We can print the result. It just goes slowly. You can say hello, now comma, what, dot, this is a text, and you can see the same, the special, I mean the question mark. Okay, that's mean it will removing the white space from here. Okay, I mean free of white space, it look like that. So the tokenizer schema with device actually here work well on the simple text. Now let's modify it little bit so that we can also handle other types of punctuation mark, such as question mark, the quotation mark, or the double dashes we have seen earlier to the first 100. Okay, we can see that the first 100 we can see also have some double dash as well. Okay, we need to also remove them from our raw text, remove them from the raw text. So how can you do that? So I am going to taking here this, I mean I'm just going to copy this out, and I am going to paste it to here, and then I'm going to give it here, let's say dash dash dash, I mean just give it here some kind of dash dash dash. So how can I remove them? If I try to make it, you can see here it unable to remove them, it unable to remove them. So how can I remove them? As well as if I'm going to using here this one as well, so I'm going to copy this out, and I am going to paste it to here, and if I run it, same thing, you can see it unable to remove it, it unable to remove it. So how can you remove it? We can give it here some kind of schema on here. Okay, so what can do, we can give it to here, we can give it to here. Okay, let's try to copy this out. Okay, try to copy this out, or we can write it by own. Okay, so let's say just take it from the this book, let's say comma dot, then you have the colon, you have the semicolons, then we have the questions mark, then you have the dash. Okay, I mean dash, we have the exclamatory signs, then we have the single quotations, and you have the first bracket, we have the backslash and backslash, and you have the single one. Okay, we have the single ones, and then as well as we can also give it here the dash dash. Okay, we can give it here dash dash, or otherwise we can give it here the spaces as well. Okay, spaces as well. Now if I shift enter, I mean if enter, and you can see here it's also removing here, I mean it will try to considering here this dash dash as a special character, that you can see on here, it's uh, making as a special characters. Okay, but in case of that I think I do any mistake. So this is the dot comma semicolons and the quotations and the strict sign and quotations, and we have these ones, we have this, and we have this. So if I strip them, I hope so, yeah, we got in here this dash dash dash. Okay, we can got in here this kind of dash, but we get it already, I hope so. So if I copy this out, and if I'm going to paste it to here just for illustration purposes, so I'm going to using here this one in the quote. Okay, so in here we can see that, yep. Okay, this dash dash is available inside this is dash dash, but in here the dash dash is separated. Okay, now we can making this dash dash as a special character, or as actual text itself. Okay, now you can see we are able to actually we actually able to convert this text into some kind of tokens. Now what I can do is simply going to apply it to our whole data, I mean our raw text, because we test it some kind of actually some kind of our input text. Now we are going to apply it to our raw text. So how can you do that? We can copy this. Okay, we can copy this, and we can simply going to make it as a pre-process. So let's pre-processed processed. I mean, just make it as a pre-processed, and you passing here the raw text. That's a raw underscore text, and then instead of making it as a result, we make it as a pre-process, and this is also pre-process. So we are going to checking the length of that. Check the length, and then I am simply going to shift enters. So you can see pre-process length is nothing but the 9. So why? Okay, the item dot strip from result. Okay, that's why I had to give it to here pre-process here as well. Okay, so we can see that we have 4690. The output is nothing but 4690. So which number of tokens in the text? Okay, without any white space, because we remove the white space from here. Now let's printing here the first 13 tokens so that you can also see this out. So pre-processed, and you can simply go into printing here the first 30 tokens. So you can see the first 30 token, you can see I had always thought Jack. This is okay. You can see it's also making this dash dash as a special of the characters that you can see. That you can see. Now our next step is to converting this token into some kind of token ID. Okay, some kind of token ID. So how can you do that? So if I see, you need to actually making into some kind of token ID that you can see. So token ID, in case of token ID, we having our tokens, sorry, our word, as well as we have our token ID. It's nothing but in the form of dictionary. So if you see in the dictionary, if you see the dictionary, if you see the dictionary, so you have the key, okay, you have the key, and you have the value, okay. So our key is nothing but one integer itself, and our value is nothing but the string. So we can creating here one kind of dictionary where you have the key and the value. So if I see in the book, you can see how they convert this token into some kind of token ID. So this is the our complete training data set. Let's say the quick brown fox jump over the lazy dogs. So we tokenize them. Okay, tokenize the training data sets that you already do it. Okay, and after that we are going to give here some each unique token is added to the vocabulary in the alphabetic order. See, each unique token ID is added to the vocabulary in alphabetic orders. In an alphabetic order. Now, how can we getting here some kind of unique token? We can apply the set. Okay, when you pass anything inside the set data structure, you may get the unique value. You may get the unique value. Then you can short them. You can short them. Then you can get some alphabetical order, and then you can give it here some kind of ID, unique ID. You can give it. Okay, let's try to implementing this out in the code. Okay, let's start implementing this out in the code. Let's see how can you do that. So we can taking some kind of shell. Okay, now we need to convert this token into some kind of Python string to an integer representation, just like the dictionary. So let's say we first you're going to shorten them, and we can simply going to pass it to the set so that we can also get here some kind of unique token, unique token. So this is our all words. So let's say all words. Okay, let's say all words, and then we can also checking the length of that. Let's say all word. So if I see that, it's nothing but 1130. It's nothing but our vocabulary size. It's our vocabulary size. Okay, it's our vocabulary size. You can say that vocab size. I mean, how many words are available? You can say that as a vocab size. And then we can simply go into printing this out. Okay, we can print in the vocab size. It's nothing but the same thing, 1130. Okay, now we are going to creating here a vocabulary and printing here the first five of that. Okay, so how can I create the vocabulary? So in our vocabulary, it's look like that. We have in key and the value. That's when we need to creating here a dictionary. You need to creating here a dictionary. So how can I creating a dictionary? So you can creating here the curly brackets. So in our dictionary, we have our tokens and we have our integers. We have our tokens. We have our integer. We have our integers. So how we can get the token and the integer? We can get it from the all what. So we can enumerate it. Let's say for, okay, for integer and the token. Okay, in enumerate, and we can simply going to passing here the all words. Okay, right now is nothing but the Okay, 37. Okay, 37. Okay, that you can see 37. रात का 3 बज रहा है यहाँ पर, इसलिए मुझे थोड़ा स्लो बात करना पड़ा है, क्योंकि सब लोग घूम रहा है ना, आई मीन सॉरी सो रहा है ना, इसलिए नहीं घूम रहा है एक्चुअली। मॉम डैड सो रहा है, इसका मेरा ग्रैंड माँ है वो भी सो रहा है, तो मुझे थोड़ा धीरे बात करना पड़ता है मुझे। Okay, so token and integers, that you can see integer, token, and the enumerate, and all the words. So this is nothing but my vocabulary. This is my vocabulary. Now we're going to printing here the first 5 just for the illustration purpose. So what I can do, you can creating here for an item in the book enumerate of the bookf dot actually items. So this is the basics Python script that you can easily grab that. Okay, so I'm going to printing it out. Let's say I'm going to printing the IDs. Okay, ID, so you can say that ID not ID actually item, and then if the I is greater than 50, we can simply go to break it out. Okay, now you can see this is the token, this is the token, and with its corresponding ID. Okay, with its corresponding ID, that you can see, and the tokens with its corresponding ID, tokens corresponding ID, token corresponding ID. Simple, as simple as it is. You can see we easily creating here this token into some token kind of ID. So you can also see it in the book. You can see token vocabulary, and also it assign here some kind of tokens. Okay, now you can see passing here sample text and we take another text. We have the existing vocabulary, and we can simply going to getting here the tokens ID from here. We can easily get in the token ID from here. Now we're going to creating here functions. I mean, we're going to creating here a class. It's called simple token tokenizer version number 1. Here we're going to creating here two methods, one for encode, another one for decode. So encode method is try to encoding the string into some kind of token IDs, and decode method is reverse them. I mean IDs to get back the text. Okay, that you can see. Okay, you can see the sample text we have, the tokenizer sample text, it have we get the token ID, and same thing we give it the token IDs, and it will we get back here the sample text. So you're going to implementing this one. Let's say implementing this one right now. So what you can do, I am simply going to taking some kind of shell, and then I'm going to creating here a class. Let's say class, it's a simple token tokenizer, let's say version number 1. Okay, so it has been some kind of problem, we discuss it later on. So now let's initialize this one. Let's say def, let's say init, and then what I can do is simply going to passing here our bookab. Okay, let's say bookab. So bookab, so bookab is nothing but this one, it having the word as well as the token IDs, so that you're going to passing it here. Now we're going to creating here two variable, so self dot string to integer. So string to integer is nothing but the bookab itself. Okay, bookab itself. Now it also creating here a variable for integer to string, integer to string. So here we can get in this integer to string, we can get it from the bookab, we can get it from the bookab. So let's get it. So let's say for I comma s in bookab dot item, let's say bookab dot item items, and we simply going to replacing them. Okay, so first we give it here the ID, first we give it here the ID, then we give it to the string. Okay, now we get it here. Now we have to creating here the two functions, one for encode, another one for decode. Okay, so it's taking here self comma text, and the decode is taking here the IDs itself. Okay, because it taking the ID, and based on this ID it will give me the text, Now let's try to implementing here this encode methods. Okay, so now encode method, what you can do is simply going to using this one, we can using here this one, we can copy this out, we can easily copy it from here. Okay, you can copy it, and instead of printing here, we are going to returning the ID. So here we can get in the ID, we are going to get in this ID from the preprocess. So we can simply going to give it in terms of string to integers. So we can get it, let's say for the s in preprocessed, because in the preprocess we having all of the string. Now we need to convert them into the integers. So we can calling here this self dot string to integer, and you can directly passing here this string that is coming from this for loop. So okay, so this is our IDs itself. So let's say this is our IDs, and then we can returning it out. Let's say return the IDs. Now we're also implementing here the decode method. So in our decode method, what I can do is simply going to joining them. So that's why we are going to using here the join methods, and then inside that we need to taking here the ID. Okay, let's say for I in IDs. Okay, from the IDs, it have different kind of IDs. We're simply going to iterate to all the IDs from here. We simply going to iterate to all the IDs from here, because this is, you can see, this is one kind of list itself. You need to taking all of the IDs, and then we simply going to give it to the integer to the string. Okay, let's say self dot integer to the string, and we can simply going to give it to here this I. Okay, that's it. Now let's make it as a text. Make it as a text, and after that, see, we just split it. We just split it. Now we need to, okay, okay, one more thing also. So you strip it, because it's a raw text, so it also using the strip in here. It also using the strip in here. Okay, I think they're not actually using it here, maybe. Okay, yep, that's my mistake. Actually, they actually use it the strip in here as well. Okay, that's my bad. Actually, it also using the strip to removing the white space. Okay, but no problem. The processing step is the similar. The processing step is similar. Okay, but to strip it so that we don't get any kind of white space when the item is the last item is actually coming up here. Okay. Okay, so self dot string to integers, and we can simply going to passing the s, and for s in preprocessed. Cool. Now we are going to converting this integer into some kind of string ID. I mean back to that. Okay. Now we need to add it. We need to add it. We need to join them with the special character as well. So how can you join them? We can using here re dot sub, and inside there we need to give it here r, and now we need to give it here some kind of a special thing. Let's say as for space and plus, and then we need to give it here the first bracket. In the first bracket we need to give it third brackets, and then we have the comma, we have the full stop. Okay, full stop. Then we have the question mark and the exclamatory signs, and you need to have the first quotations, and then we have the first bracket. Okay, then you have this backslash n. Same thing we give it before, to also give it to here so that it can join that. And after that you're going to give it here this the r. So let's say r, then you give it here the one of the text. Don't worry, you'll get this code in the description. Okay, now text, and after that we simply going to returning this one. Okay, let's make it as a text, and then it's simply going to returning here text. Okay, return the text itself. Okay, it's as cross check like this one, and we have the dot full stop, the quotations, and the first bracket, and this one. Okay, okay, let's check this out. Now let's running this out, and then we are going to calling here this simple tokenizer version number one. So here you're going to passing here this our book app, and then we are going to make it as a variable called tokenizer. Okay, tokenizer. Okay, tokenizer. It is simple tokenizer b1s, and then you're going to give it here on text. Let's give it here on text for the testing purpose. Okay, so let's give it to here. Let's say it's okay. Let's say it's the last he painted, you know. The next one, then let's say Mr. Gisborne said with the pardonable right. Okay, just give it here some kind of text. Okay, for the testing purposes. Now we're going to using this tokenizers dot encode method. So let's encode, and you can pass it to the text, and it will give it the IDs. So we can simply go into printing this out. Let's try to printing it out. That's IDs. Okay, anything wrong? Okay, bookab items is not defined. Okay, if the bookab item is not defined, okay, it's nothing but the bookab dot item, sorry. Okay, now you can see those are the id from the text. Okay, maybe give it here some kind of wrong information. It should be the text itself. Okay, because it is passing to the parameters, that's why it's coming. Yep, now we got the output. So 562850988 blah 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 blah. Okay, now we need to get back this text again from those token ids. So how can it do? We can simply go into printing it out. Let's say tokenizers, and then you can simply go to decode it. Okay, let's say decode, and you can passing these all of this id. Okay, now you can see maybe some kind of error, key error 56. Okay, key error 56, that's mean we may get some kind of error in here. Okay, so integer to string, and you can passing here this I. So let's see what this I. Okay, I and s, for s comma I. Okay, it should be s comma I, because first it will give the string and then it will give the integer, because you can see it will first give the string and then it will give the integers. Okay, that's my bad actually. Now you can see it's got back the text again. It is the last he painted, you know, the Mr. Gisbung said the pattern right. Okay, so we got in here the text to the actual things that you can see. Okay, we got in that. Okay, now here is also one problems. Last, I am going to copy this out, and instead of give it here this text, I'm going to give it here another text. Let's say hello. Okay, hello, do you like tea? Okay, do you like tea? Now if I see shift enter, then you can see we got one error. That's called key error hello. Key error hello. What does it actually mean? It's mean that hello world is not available inside this verdict. Hello world is not available inside this verdict. That's mean this word is out of context. The word is out of context. Now how can you handle it? You can adding here some kind of special context token. So you can go to the book right now again. So go to the book again, then you can see here you go, you can see. So adding here some kind of a special tokens. See, so in our case hello world is not available in the verdict story. In the verdict story, that's when you're adding here some kind of special tokens, like you can adding here on unknown tokens. See, the sample text, the brown dog playfully chase the swift fox. You can see here after this chase, this word is not available. I mean, this word is not available inside our vocabulary, inside our vocabulary. So what it can do, we can add here to special token. One is called unknown token, another one is called the end of text. So why this end of text? Actually, we know the unknown token is nothing but if the word is not available, we just make it as the unknown token. Now, what is that? It means end of text. End of text. It's mean, let's say we have some kind of data, because we know that in case of the large language model, it will train a vast amount of data or vast amount of book. Let's say I have 4 document, 1 2 3 4. So or in the PDF I have the 4 pages. So when one page is ended, then you can add it here one token end of text. That's mean this PDF page is end, and next that's mean next um, page is coming. Okay, you can see next page is processed. Okay, it had the 1 2 3 4, it had the 4 document. First it will process them, and after that it will process this one. So when this processing is done, then it will add here one tokens called end of text, so that we can understand that this is the page number 2, or this is the book number 2. Okay, so you can add here 2 tokens, one called unknown token, another one is called end of text. So you can see it is added to here some kind of spatial token. Okay, now let's try to implementing this one. Let's try to implementing this one. How can you implementing that? Okay, so now let's modify the vocabulary to include this spatial token the unknown token and the end of the text by adding them to our list of the Unicode. So how can you do that actually? We can simply going to short it first. It's a shorted, and then you can creating here a list, and inside this list you're going to make it here. I mean, you can give here all of the pre-processed text. So this is nothing but our all of the tokens. So here you can get all of the tokens because in our preprocessed we have all of the tokens. I mean the function, if you can see, so no, not function actually, the variable you can see the preprocessed, you can see preprocessed, it have all of the tokens. So we're simply going to creating here a list of that. Now from this list, from this list we are going to adding here those special tokens. So this is nothing but our all tokens. Let's say all tokens, and then we're simply going to extend it. Okay, we can extend it. Let's say all token, okay, should be all tokens dot extend, because this is a list itself. And then we can simply extend it here, two things. Okay, one is the end of text. Okay, see, end of text, end of text, and another one is called the unknown tokens. Let's say unknown token. So let's say this is the unknown token. Let's say UNK. This is called the unknown tokens. So let's add it. It's better we can taking some shell. Okay, and then we simply going to add it to our vocabulary. So let's say vocab, and then you can enumerate here all of the tokens. We can easily copy this from here. We can easily copy it from here. Okay, okay, tokens, because this is a dictionary itself, so we need to creating here. Okay, this one. Okay, we can copy this, and we can simply going to paste it to here. So you have the tokens and the integer. For integer and the token in enumerate of the all of the tokens. So it should be the all of the tokens. So let's say all of the tokens. Now we have the vocabulary. Now we can simply going to printing it out. We can printing here the length of the vocab dot items, because this is a dictionary. We just checking here the items. Okay. Now you can see we have the 1132. So before we have 1130, right now we have the 1132. Yep, 1130. Now we have the 1132 because we adding here two special token. One is the unknown token for handling the unknown tokens or unknown words, and another is for the end of text, so that you can also check that if the document is coming from page number 2 or page number 3, page number 4, or like that. Okay, if the first page to document is ended, then you can see that this after that we can say that this is the next page. Okay, that's it. Now you can also printing this out. You can say that for the item in enumerate, and you can simply going to give it here this bookap item. Okay, so bookap dot item, and we can simply going to printing here. Let's say I'm going to printing here the last five. So we can, okay, for I in list, we need to also give it here in the form of list, because this is a list itself. So you can also see in terms of list. So let's say we're going to checking here last five. Okay, then we can simply go into printing the item. Okay, let's say printing the item. So you can see those are the end of text, and the unknown token is added to our vocabulary. Now you can simply go into changing this simple tokenizer b1. So you can copy this out, and you can simply go into change something on here. Let's make it the 2 first, and after that we are going to add it here one unknown tokens. We're going to add it here unknown tokens. So we can add it here. So what you can do first, if the, okay, if the item in self.string to integer, okay, is available, we can directly actually passing here this item. If it is not available, if it is not available, we can just give it here the unknown token. So how can I do that? I need to give it to the list comprehension. So for item in preprocessed, because all of my item is available inside this preprocessed, and then we checking that if the item, okay, if the item in self dot, okay, self dot string to integer, string to integer, that's mean if it is available inside this string to integers, then we can simply go into return here this item, return here this item. Otherwise we are going to passing here the unknown token. Okay, unknown token. Okay, it should be the here. UNK. That's an unknown token. UNK. Okay. So item. Okay. We getting here all the items from here, and then we check in then if the item in self dot string to integer, then you can just give it here the item. Otherwise, we just give it here one unknown tokens. Okay. Now we can simply going to give it to here, and then we are going to actually run it now. So this is a simple tokenizer B2. So we are going to copy here this tags as well, and then we are going to give make it as a 2. Okay. Now you can see to convert them into some kind of tokens, and then after that what I can do, we are going to decode it. So let's try to decode it as well. Let's try to decode it. So you can see it gave me some kind of unknown token because it's nothing but an unknown token itself. Now let's try to print checking here the end of text as well. So what I can do, I'm going to taking here text to text. So text one and text two, and after that I'm going to join them. Okay, let's say hello. Let's say hello. Do you like tea? This is our text number one. We also give it here one a question mark, and then inside that I'm going to give it here in the sunlight. Okay, let's say terraces of the palace. Okay, palace. Okay, that's it. Now you're going to joining them. So let's say text is equal to, you're going to add it here the end of text tokens. Okay. Okay, it should be the end of text, because this is an text document number one or text source number one, or this is a text source number two. That's when after text one we can adding here the end of text. Okay. Now we can simply going to join it. Let's say join, and then inside that you're going to give it here the text one and the text two. Okay. So in the end of text we are going to give it here some kind of space. Okay, that's it. Now you can simply going to printing here this text. Let's print the text. So you can see do you like tea, and you can see end of text, and in the sunlight. Okay, not sublight. So you can see this is okay like that. Now you're going to using here the simple tokenizer, where you having all of the vocabulary. Now you're going to using here this one tokenizers dot text, and then we're going to printing here the IDs. That you can see we also printing here the IDs. Now let's decode it. Let's decode it. And now you can see UNK, do you like tea, and end of tokens. You can see end of token. That's when we are get back this one from here. Okay. So that's all about from my side today. And in the next one, we're going to discuss about on byte pair encoding. What is about that? But we can also depending on the large language model, some researchers are also considering some kind of special token as well. So I can also write down on here. So I need to connect here this pat as well. So let's first go on the okay, let's first go on the actually the drawer, the mirror. Okay. Okay, so I'm going to give it to here this drop pad. There also have some kind of actually spatial token like BOS. So let's say BOS, also called the beginning of sequence. It's called beginning of the sequence. Okay, the spelling should be beginning of the sequence. And also have the BOS. Okay, BOS also called the, sorry, not BOS, actually EOS, also called the end of the sequence. And also have the pad, it's for the padding. And the token that you use, end of text. Okay, for the unknown handling, we're actually using here this UNK for handling the unknown tokens. So those are the token is generally actually used by the researcher: BOS, EOS, PAD, and the end of text and the UN key. So Those are the token is usually used in terms of checking the beginning of the sequence or the end of the sequence, as well as for the padding. But moreover, the tokenizer used by the GPT model are don't using here this kind of the spatial tokens or a special tokenizer technique for out of vocabulary problems or any kind of padding problem. Instead, GPT model, instead GPT model using here a byte pair encoding tokenizer. Byte pair tokenizer encoder. Let's use them. Byte pair encode together, which break the word down into some kind of subword unit. Subword unit. Okay. So which we will discuss in the next tutorial. In our tutorial number 3. So that's for today now. I hope you enjoy this full tutorial and make sure to subscribe our channels and like and also comment below because मुझे inspiration मिलते हैं बस. Okay. Namaste and bye bye.